first part has to use the shell method.
Yeah. The first part was making sure you still remembered how to do the shell method. You guys remembered that we reviewed the shell method yesterday? Well, we did washers or shells, but shells were the easiest and most straightforward way. So a few more shell guys, and then we went into arc length and surfaces. This is all the new stuff in Chapter 8 for you. So that was just one last shell method where you're able to plug in, hence why there was a 2 pi. I did have the question yesterday, can we just forget washers then and just do shells, because shells are washers simplified?
No.
Shells are not always washers simplified, depending on the bounds. If for any reason your radius for a shell, cylindrical shells, if your radius changes, it's not always easier. But also the AP, remember how it has those questions of write but do not evaluate, or multiple choice answers that are integral expressions? If there is no 2 pi, or I should say, if there is no shell variation but a washer one, you have to be able to make it match. So that's another reason to not forget washers, but yes, shells do make some of these washer problems easier. Anyway, that's the final setup to the shell method, and then we go to arc length. So number 22 is the first arc length problem, I think, as far as the first even. Someone asked me yesterday also, when your classmates said, do we have to plug every single one into our calculator? Why are you plugging into your calculator and not solving by hand, even though both of these so far have said that you could solve by hand? This chapter focuses on the setup, yeah. However, on the test, could there be some where you have to, what do you think I'm going to let you use? A calculator. However, as I let you use your calculator, could there be some making it matches that are numbers and not just integrals? Do you know what I mean? Could there be a 6? Or could there be a 49 pi over 3 instead of just the integral? Yes. Well, wait a minute. If it's a 49 pi over 3, I'm going to get a decimal. Am I going to have to plug in A and B and C and D to make the decimal match if you're letting us use the calculator? Yes. Or you could just solve it. I mean, I don't know if using the calculator for the entire test is going to be completely useful. And remember, if I'm letting you use your calculator for the test, pause. Will some of those questions be non-calculator type questions? Yes. So if you do find some sort of weird random shell washer disk program that you can download on your TI calculator, or if you do for any reason have like other, let's just say, programming to try to cheat the system, are you technically missing the point of those non-calculator questions that you won't even have a calculator on? Yes. Hence, when I grade your Chapter 8 test tomorrow that you take, I'm not just grading the final multiple choice answer since you have a calculator. I'm also going to look and see if you have a proper integral expression. Does that make sense? And some of you might be like, well, duh, how do I use my calculator if I don't just plug in the integral? Well, I'm sure there are programs out there somewhere that someone is trying to cheat the system in their calc class where they can just put in a function and something can get them some sort of approximation for the volume close enough to make the right match. But here's the point. You're not going to be able to use it on the types of questions for which it'd be helpful on the AP. Does that make sense? Like, they design calculator problems to not be able to use those programs. And so thus, tomorrow on the test, if you just have the correct A or B or C or D, you're not going to get the full points unless you have a correct integral expression. And I see lots of little smirks. I'm not exactly sure why they're there, besides the fact that I'm really glad I made that announcement today. Ryan, what's up?
For problems that are in terms of y,
Mm-hmm.
I don't really, is there a way so you can switch the variable you're using?
Well, if you're using the integral feature of like to numerically integrate with your calculator, to be honest, the calculator doesn't know the difference between x or y. It just says, hey, variable, cool. So you could technically take an integral in terms of y, which I don't think we've come up against one yet. All of these are in terms of x. If this was dy, Ryan, let's just pretend that was a y and this was a y. You could put it in with x in your calculator, and as long as you've set up your bounds properly and the equation properly, it doesn't matter whether it says x or y in your calculator. But if you're trying to graph something, and you're trying to figure out what something in terms of y looks like to make maybe some intersections or to do something like that, the only way to graph something in terms of y is either To switch x and y, look at it in terms of x and pretend it was reflected across the y equals x axis because it's an inverse. Or the only way in the calculator to switch x and y is to change to parametric mode. Because only in parametric mode, where's my function? Oh, it's down, sorry. Only in parametric mode can I do something like graphing a non-function. Check it. If y is t and x is t squared, isn't this a graph of x equals y squared? Only in par mode can I graph. Now, you might have to change your window to have some negative t's and some positive t's, but only in par mode can I graph non-functions. You see it? So if you ever do want to visualize something where it's an x equals, you can always make y the t and x equals whatever it is in terms of t. Just couple heads up. You need to be in par mode, and your window needs to have negative and positive times so you can see the full situation. Now, it's not full. It should keep going, right? But it gives you an idea. But it doesn't really help you with integrating, sadly. But once again, well, I mean, technically, if you're doing an integral, some of you like throwing that function in here because you're used to FRQs, sorry, function mode, and then using y1. You're just used to FRQs. That would make you graph it anyway, so why not just get used to using it? But there is technically, from the home screen, there is a way to do a derivative, and with that derivative, if it makes you feel better, you don't have to use x's. You technically could use alpha y's, and as long as you make whatever it is in here the same letter, it knows what to do. So if it makes you feel better, you could put y's in there. But once again, if you do have something in terms of y, you can use x. X is just an ambiguous unknown variable to the calculator. It's just saving a variable spot. So that's totally legal for you to do. Sorry, 34 was D, 36 was B, and I think I gave you the rest odds on purpose so you could grade. Now guys, I do have the webcam, I have it coming up, and I do have your book right here if we need to talk about anything from section 8.4. But otherwise, I'll give you a piece about the chapter 8 test before the end of class is out and let you guys have a work day. But is there anything from those of you guys that were working on homework? 19? Anything else that you want to talk about? 49? Are those the shell ones?
37.
You know what I mean, AJ? Are those the...
Yeah, those are like part one.
Okay, so it's the shell ones.
Yeah.
Okay. That's good. That might be something that'd be more beneficial for me to work with on you. Or with you alone. You know what I mean? Unless someone else... Did anybody else get stuck on shells? Oh, we were stuck on shells on here. Let's start with arc length and surface. Anything else from 424? I have 11, 19, and 37. Anything from the second page of homework? The page 424. Okay, as you guys are pondering, let me go ahead and go grab number 11 because he's right here. Number 11, we're trying to find the exact length of the curve. Any of these questions, 11, 19, or 37, was it about solving or just setting up? I'm going to set up, but does anybody need me to solve? Like, were you trying to solve, testing your skills? Okay. Solve by hand or solving with calculator? Exact length, yeah. Simplify the integral before finding an antiderivative. Okay, are we doing arc length? Yeah. Okay. If you don't need me, if you don't need this, you guys know what to do. Put music in or whatever you need to do and be working on your review. This is AP Calculus BC 10 though, so I don't want to see any other concepts. Okay. I'm going to go dx just because remember we don't have to. No, it's not calibration, it's the program freaking out. It's okay, I'll reload it. Calibration would be a little bit off, that's a computer issue. Remember, if you guys are working on something else, I am so sorry, you're going to have to either write notes to each other or mouth it because we're really bad at this right now. Okay, here we go. dx. Who goes in the for arc length? Who goes in the square root? Derivative. So therefore, I could bring down my 3/2. That's going to be 1/2. I'm going to have this guy to the positive 1/2 power. Oh, he was nice. Oh, don't forget your u prime. So I brought down my 3/2. I have a 1/2. This to the positive 1/2 power times u prime. And then my 2's reduced. I end up with x squared root of x squared plus 2 squared. If I'm supposed to do this by hand, hey, it says 0 to 3. I plugged into my formula. It's great. It's good. How much visualization was there necessary to plug into that arc length formula? None. All we had to do was have the formula memorized and be able to do a derivative. Are we good? I'm going to go ahead and start playing with the solving. So I'm going to have an x squared times, because x times x, and then square root squared x squared plus 2. Remember in our book, guys, this is in chapter 8, and there might have been a couple sections that we skipped along the way with integration that weren't necessary. Just keep that as a heads up as you're looking at some of this work. I see a square root in that integral of x to the 4th plus 2x squared plus 1, which would be really nasty with u sub unless I realize this is x squared plus 1 squared. If I factor. True? This is x squared plus 1 quantity squared if I factor. Oh man, square root squared, go team. It's technically an absolute value, but if you notice, this is always positive anyway. The absolute value doesn't change anything. It could be dangerous in other problems. And from 0 to 3 is always positive if you were even just looking there, so the absolute value would not have a meaning even if it could change signs. But basically, long story short, all I need is 1/3 x cubed plus x evaluated from 0 to 3, which is going to end up with 27 over 3, which is 9, plus 3 minus 0. The answer 12. That was a very nice one to solve by hand because this nice little simplification was a perfect square, so the square root went away. Go team. Number 11 is a check. Any final clarification on 11? Okay, number 19. If my computer shifts. Is a group activity. Sorry, you had a group of 1 last night. There's a group activity where, okay, they want you to find a curve through. Ooh! Is this kind of like a going backwards problem? It gives you a function for the arc length and says, hey, this is an expression for the arc length. Where did it come from? What was my function? Great question. Super interesting. I liked it, which is why I find it, obviously. Find a curve through the point. Does anybody see this as my initial condition? They've given me hey, f of 1 equals 1 clue. And then if I look at this, doesn't this fit the form of 1 plus the derivative squared? So can't I go ahead and say that 1 over 4x is f prime of x squared? You see it? How do you go backwards? Or I can square root both sides and I end up with 1 over 2 square root of x, square root, square root. 4 square root is 2, and I have the root of x. That equals f prime of x. So how do I get to f of x? It's a very hidden solving the differential equation problem. So I have dy is equal to 1 over 2 root x dx. But some of you realize this is a guy that we've seen many times. Because 1 over 2 x to the negative 1/2 is what happens anytime you take the derivative of square root of x. You could have done a power rule also and said like, oh hey, that's 1/2 x to the negative 1/2 plus 2 over 2 all divided by negative 1/2 plus 2 over 2. You could have solved it with power rule, but that's what most of us would recognize. Plus c. All I have to do is go plug in my clue and say, aha. So square root of 1 is 1. C must just be 0. So therefore, y equals root x. Now letter B says, how many such curves are there? Such curves. If they're asking through the point 1, 1, there's only one, and that's it. If they're asking for curves such that the arc length is the expression, you could say infinitely many. Any of the ones, there's a whole family of antiderivatives of the form y equals square root of x plus c. It was an oddie to go check it out, but if they were saying this had to be true, it's a little bit ambiguous in how they worded it. If they were saying this had to be true for both, how many such curves are there? Just one. Only one goes through 1, 1. 2 through 1, 1. Oh, nice. Nice. I didn't deal with absolute value on this one. I meant to. I didn't. Because you could have had, to get the 1 over 4x, it could have been a positive derivative or it could have been a negative derivative. So the infinitely many is not the case. They are saying through the point 1, 1, but they are catching whether or not you were careful. Over here, say square root of a squared absolute value, f prime could have been a positive or a negative, so f prime could have been either positive 1 over 2 root x or negative 1 over 2 root x. If you plugged in either of those, you would have had the exact same arc length expression. Thanks, Brenda. Wow. Someone who harps on absolute value, I'm sure didn't use it today. So over here, you could have had a plus or minus, which would have resulted in this, and basically being a plus or minus, which would have resulted in this being a plus or minus. Good question. Number 37. Any quick clarification on 19 working backwards with a differential equation? Okay, number 37. He was a multiple choicey one, and you're just trying to write the expression. Ooh, we like expressions. My guess is they did some funky simplifying that you guys didn't like, because otherwise it should be fairly straightforward. So what kind of yucky simplifying did they do? Which of the following expressions should be used to find the arc length of? Nasty! It's in terms of y. No big deal. How do we get something in terms of y? Solve for x. So couldn't I do y to the 3 halves is equal to, raise something to the reciprocal power. If I have a cubed root, I cube it. If I have a 1/2 power, I square it, or square root. If I have a 2/3 power, I raise it to the 3/2 power, because the power to power multiplies. That reduces, that's just going to be x to the 1. I raise what I do to one side, I do to the other. I'm not done yet. I still have to plug into my arc length formula. My arc length formula would say, ooh, they do an L. I don't like that. I use S, but okay, fine. L, S, whatever. The integral. Can I put negative 1 to 1, or should I go through and right now get rid of anybody who's negative 1 to 1? Well, or should I look more closely? What are my negative 1 to 1s that they gave me at the beginning? X bounds. How do I find Y bounds? What happens when I plug it in? What's 1 to any power? What's negative 1 to any power? No, it's not a cube root. It's a square root, which we don't usually put, of a negative 1. Wait a minute. Are 1 and negative 1 y's or x's? X's. Why am I plugging it in the y spot? I know it's a great question. I'm actually asking myself too. But wouldn't you have to plug in x is negative 1 and x is 1? Maybe it would have been easier then just to plug it way back here and say, okay, what's happening if y is equal to the cubed root of x squared? Maybe it'd be easier to plug in 1 and negative 1 here. So negative 1 squared. 1. Wait a minute. Aren't those both 1? Should I be going from 1 to 1? Now we're lucky. Look at A and B and C and D and E. Are any of them 1 to 1? No. It'd be 0. So first of all, I'm definitely going to cross off negative 1 to 1. That's not a thing. But second off, why am I going to be like, oh, it is 0? Why am I going to say, oh, it is 0? Kind of symmetry. kind of, sort of. If I was asked you to graph this guy, I could go ahead, and if it would help, I could go x is -1, x is +1, y is 1 on both. You could think of, wait, I think I have some sort of curve. I could plug in 0, 0, 0 as another point. Maybe you could start to make some hypotheses about what this guy is. X does go from -1 to 1, but isn't y going to go from 0 to 1? Anyway, we're still trying to plug in. So we have 1 plus f prime squared with a dy. We got this guy as our, here he is, as our f of y. So bring down the 3/2. Make it y to the 3/2 minus 1/2. And don't forget your u prime, which is just 1, because in terms of y, I don't know. Some of you might want to rewrite this as a 3/2 square root of y. Makes your life a little bit nicer. But 3/2 times 3/2 squared ends up being a 9/4. The square root squared is a y. So I have 1 plus from 0 to 1 of a dy. Why it's double.
Yeah, so it's like, in this case, you're assuming that the graph will be symmetry. So what if it is a graph that you don't know about? It is non-calculated.
I mean, symmetry is definitely something that the AP tends to incorporate into their functions. But I understand, Lorenzo, you're trying to be ready for non-symmetry. I mean, you guys aren't devoid of skills. I was telling Lainey today that after school this week, CalcAB kids will not only be working on final review problems, aka practice multiple choice from their first semester, but also corrections on their last test, which was critical numbers, increasing, decreasing, relative extrema, points of inflection. Could you take a quick first derivative of this guy, whoever he is, and think about critical numbers and think about whether there are mins and maxes and where they are? Like, if worse comes to worse, usually though, Lorenzo, you're right, a question shouldn't require both the analysis of that and an arc length. So I guess it's possible that they make this a much more involved problem, but they shouldn't. It should be a similar symmetric function to help you out. I do have negatives and positives, though. And I do have a cube root function of x to the 2/3. I'm trying to figure out why there's a 2 in front, but maybe that's something silly to do with me. What's your justification for there being a 2 in front, Lorenzo? They what? Mm. This 2 indicates it seems to be some sort of doubling, but I don't know why it's doubling. Let me grab quickly the solution menu. So I don't want to waste time if it's not going to lead anywhere productive for the whole class. They double it as though there was... There's y-axis symmetry. It is an even function. It's not an odd function. Why is it y-axis symmetry? No, that wasn't the question.
No, like, since you have dy with respect to y, something with double respect to symmetry over y, which makes sense because it is dx first. I don't think you can pull out the dy.
Oh, I did it again. Absolute value. I did it again. I forgot my absolute value, Lorenzo. That's what I should do. not as simple as just y to the 3 halves. It's technically plus or minus. Which means this curve for x equals y to the 3 halves only gives this one. I would need the negative. I did that wrong, I'm sorry. I would need the negative to get over here. So instead of doing that, their integral expression is just here. And so from 0 to 1, I only have the arc length of the positive part of the inverse and not the negative part, but I need of the entire function on both sides. So I should have seen the absolute value. I just did fast with the reciprocal power, and I didn't think about how I was square rooting a square. That was my bad. And the absolute value would go ahead and, well, the easiest way in my mind is to go ahead and take a piecewise function. A piecewise function would have just both a positive and a negative. So that's your indicator, is this right here. So you needed two different functions to describe. And so then with the even symmetry at the top, if you have two different functions to describe, instead of taking the integral of one plus the integral of the other, I could just double. Yeah, good question. Absolute value, two different problems. Struggle. Sorry, guys. I'm not on top of my absolute value game yet. I have AJ with some shell questions, and then maybe you were wondering something about the shells too. Do you have a particular one from that first page?
There's 2 questions. Shell problems. 49 and 57.
These two, the first two. AJ, is that good? 49 and 57?
Yeah.
Okay.
And 61 and
We're multiple choice.
no, they were the same.
Oh,
It's the direction of
got it. Okay. So 49 tells you to do it 2 ways. Someone was asking me yesterday if you guys actually had to in homework. To be honest, it would have been good to do because, once again, the AP could make the correct make it match answer a washer method, or it could make it a shell method, technically. So it's okay to have both in mind. But if it was just a solve, you just need to have the one that works for you, to be fully honest. And this one is 1 over square root of x. We know that x can't be less than 0, so we can ignore everything on the left-hand side. Right, domain. If you're one of those that wants to consider those things. And square root of x, well, square root of 4, square root of 9, square root of 16 is kind of making it more stretched out, I believe. But either way, you have a vertical asymptote, you have a horizontal asymptote. They give us this x equals 1/4. If you're a visual person, that might help. And it says the line y equals 1, which must intersect somewhere. We could plug in y equals 1, and 1's going to occur when x equals 1, so you can kind of like cheat a little bit by plugging and chugging and realizing some of our dimensions. And x equals 1/4 is going to intersect somewhere also. So square root of 1/4 is 1/2. 1/2 flipped reciprocal is 2. So we have a few different things just by kind of plugging and chugging the x's that they gave me to get y's, or the y's that they gave me to get x's. And they tell me it's revolved about the y-axis, which I see some hollow space. If you guys like washers, you would have to start here and go out for big arc, and start here and go out for little arc, having right minus left and right minus left, and it would all be in terms of y. That would be this one that I can show in a second. This one. No washer. But the shell method, instead of going perpendicular to the axis, we have to think about that, but we're not using it. We're going to go parallel, so we get a different color. And go parallel to the axis. If it helps, you can actually have it revolve and make a cylinder. There's that radius. And this one, if I'm going parallel, that thickness is a dx. That's okay. I had a nice solid hole. So I'll do shells first. My dx is from 1/4 to 1. So I'm going from this x to this x that I found by plugging and chugging my y and solving for x. I have my r, which is horizontal. It's from 0 to out at the point, so it's just going to be an x. X minus 0 if you want to be super precise. It's horizontal, so x and x minus the lower x, x minus 0. That helps. And then I have my height. And my height is my top minus my bottom in terms of x. So my top is that dude. And my bottom is y equals 1. Whereas shells would have gone another direction. Shells would have sadly have had to have been dy instead. I would have had pi with a dy. And I would have had to have had my big R squared minus my little r squared because of that hollow space. My big R would have been who's on right minus who's on left. And that's x equals 0, this line. But yeah, we're going to get this in terms of, I would have had to multiply to the other side, divide. So 1 over y, and then I would have had to square it. So who's right minus left? It'd be that little, which makes it messy because it's kind of ugly now. Minus, and then right minus left would be my 1/4 minus 0. That would have been number 49, going either direction. The setup is just a bit harder on washers, but not impossible. The setup was a bit more simple on shells, but only if you see it. And then number 57 was the other one, right, guys? I see. 57 just says find the area of the surface. Ooh, area of the surface. Oh, I only did one shell. Oh, okay. Sorry, I missed it. I thought I did a few more. Area of the surface is that second endeavor, endeavor number 9. That says S is equal to, I need my frustum, I need my 2 pi r in terms of, and then L, which is arc length. I'm going to get my arc length set up and ready to go. Need to, at some point, figure out if I'm doing dx or dy. What do you guys think about the way it's oriented if it doesn't truly matter? Yeah. Everything's in terms of y. That'd be kind of nice. But remember, what you're plugging in needs to be f prime. True? So then x prime, in terms of y, I just do good old-fashioned 1/2, y to the negative 1/2. I don't need dy dx because I'm taking d dy of both sides. I'm finding dx dy to plug in, or x prime y to plug in. So I'm good with my 1/2 square root of y. I just need to figure out my r. That gets a little bit trickier if you don't think about, wait, isn't that y equals x squared, just one side of it? If I were to like solve for y equals, and then y equals 0 to 2. I got that piece. And where am I going about? The y-axis. So when I go about, it's like an outer edge of a cut. So my frustum would be that little ring going around. And so the radius of that little ring would be horizontal. X minus 0. But the awkward part of that x minus 0, well, who is x? My r equal x minus 0, which is y. Who is x? The hard part on this one for surfaces of revolution is who is your r. Visualizing does help. Knowing where the axis is helps. If I'm revolving around a vertical, I'm going to have a horizontal radius. That horizontal radius needs an x measurement. If I'm in terms of x, no big deal. Just use x minus 0. But if I'm in terms of y, I have to plug in. Kind of similar to some of the hard things with shells. Anything additional? In the sense of, let me see if this would be one we could do by hand. That square root would go away, you would get a common denominator of 4y plus 1 all over 4y square root of the square root of y on the outside. Strictly a decimal answer. You could throw your y in. That would be, well, they both have square roots. 4y squared plus y. Oh no. He's in the numerator, not the denominator. All the oh, sorry, I didn't plug in my counts. Square root. Which you can make that 4y plus 1 over 4y, but with a square root. Yeah, David, that would be. Okay. Let me go ahead and go. Uh-oh, I think I just deleted him when I did 57. But I can pause the video towards the end of class and go back and let you see it. Some of you are hopefully, some of you, all of you, are wondering what on earth is on this test tomorrow. Should we talk about that? We'll strategize our study a little bit. Okay. So far, we have said that you are allowed to have your calculator, but if it is a question, all right, hold on, you guys are calculus students, so it is my advice that you turn on your listening ears and your taking counts to hear the hints, advice I have for your test tomorrow. Sound good? To record?
No.
Oh, to type down notes, yeah. Sorry, I was like, I guess you want to get every single word I said. Although it's on the video. Anyway, okay. For any area or volume or arc length or surface of resolution question that is not an integral. Does that make sense? For any answer that is not an integral, what does that mean? You have to actually solve, not just set up. Are we tracking? For any answer that is not just an integral, what did I already say today you have to show to get full credit? An integral expression for how or where that answer comes from. True? But all that to say, the first one, hey, look, it's just integrals. You just have to choose which one's right. What are some different things you're going to have? Area. Find the area of the region or the area between. I think they're both area between so far. One of them you have a graph, one of them you have to find the graph. Oh, you're going to have your calculator. Oh, but what if it's in terms of y? Good thing I answered that for Ryan today. Yeah.
So whenever it says like find the area, is it always like the actual area like with the same surface, or is it like this one was just
No, if it says something about find the area and it mentions the word geometry, then you're going to do triangles, rectangles, but that's not this test case. So if they're saying find the area, I bet one of the boundaries is going to be a curve that needs an integral, like an area between. Yeah, like an area between. Good question though. So remember area, that's area between, which I think is section 8.1 or 8.2 or maybe both. Volume of something revolves, that means a non-cross-section, even kind of a cross-section. Oops, something else revolves. Ooh, one was in terms of x and one's in terms of y. P.S. Absolutely none of the answers on the test are decimals. What does that mean? If you're using your calculator and finding decimals, you're going to have to make it match. Unless you just want to do it by hand and hopefully get to the correct answer. Well, depending on the problem, if it's just a simple power rule, it might not be a big deal just to do it by hand and not have to go match all your decimals. Just saying. Sorry. volumes about horizontal axes that are way far away, volumes around axes that are right on the axis. Ooh, one does say use the shell method to set up and solve for a volume. That means when I look at your integral expression, it needs to be a shell method. Now, could you use the washer method to get the right answer and then just hope that I kind of take your pretend shell method? Anything. Or you could get the points for the multiple choice and not for the work. But find a volume around a vertical line. That's a little bit removed. Ooh, you get to choose what method you want to. Oh, we did one like that yesterday. You got to choose what method you wanted to use. An arc length problem, and those are all the multiple choice. So what's the long answer? A surface, area of a surface is a long answer. Just to set up, not solve. Cool. Good. Those setups, those solvings are nasty. That's like what you just saw. Surface of revolution, a setup but not solved. And then a shell method of something without a picture, and I tell you to use a picture. But it's a basic graph. It's not going to be something crazy where you have to like go plug it into a table or anything like that. So there are a couple that you guys get to choose what method you want to use. There are some that just say find volume, so it's up to you as to what you want to use and how you want to use it. But I do make you at least have 2 to 3 that you actually use shells on. But for some of you, you're like, I don't mind. Shells are usually easier than washers. So all in all, you have what? 9 multiple choice and 2 long answer. Shortest test all here, kind of. 9 multiple choice and 2 long answer. Shortest test all. Kind of. Kind of. 2 pages, 3 sides. It's a short one. Why? It takes some time. Oh, maybe that's also why for every question that has a numeric answer, I'm giving 2 different credits for the multiple choice and for the work. So in a sense, each of those are worth double. All right, guys. Any quick questions on the chart? Do you need any reminders like cell phone charts or phones or homework spirals? Oh yeah, I have to do the homework spiral and notes from last test too. That was gone. Double grade. That'll be fun. Have it ready for me though, and it'll go easy, and I won't be as frustrated because I should be able to look at your table of contents and be like, it's all here. Oh, it's all here. 100. And same thing with your homeworks. P.S. Grade your homeworks, please, and make it obvious. The review is due tomorrow. Logistic. Oh, come early, please. Just kidding. You don't have to come early. Stay late if you want. If you need. And I'll see you guys later. I'll be here after school. ABers are working on L'Hopital. Some of you guys, you would love to do that. L'Hopital or Chapter 3B is like 14 identifiers. Optimization, maximum. And using tangent lines for linearization. And I'm using the L of X formula like you guys are using this year just to tie together A, B, and B, C. So that'll be nice. The notation that we use. Question? Yeah.
I was checking yesterday and yesterday. No. And I just.
It's not a really long video. It's just it was a demonstration.
How did you check it?
I checked Friday night and today.
I wonder if I didn't put it in the correct playlist because it was up.